So let's take a look at problem 146 on number 23. What we're going to do is we're going to use the definition of derivative to find the derivative of function f, and then we'll use that derivative to find the slope of the tangent line so we can find the equation for the tangent line through the curve 1, 3, and then finally we'll sketch a little graph of this thing. So we begin this problem using our four-step process for finding the derivative. In step 1, we're simply going to compute f of x plus h. That means we plug x plus h into our function, and then if we do our algebra correctly, we'll get an expression. So that's going to be 2 times x plus h quantity squared plus 1. Let's FOIL this and simplify. So I get 2 times x squared plus 2xh plus h squared plus 1. Distribute the 2. I get 2x squared plus 4xh plus 2h squared plus 1. Whew. Okay. In step 2, we have to form the difference, meaning we're going to subtract the original f of x from that. And actually, an easy way to do that is the old-fashioned way where we just line these things up. So the original function was 2x squared plus 1, and I can just do a little bit of old-school subtraction, and notice that these guys cancel. And I end up with 4xh plus 2h squared for my difference. We'll use that in the numerator and part 3 and divide by h on the next slide. So for part 3, we're going to form our quotient, which was 4xh plus 2h squared over h. And notice we can factor an h out of there, so we've got h times 4x plus 2h over h. Those h's will cancel, and we can now do the limit, step 4, and find our derivative. F prime of x, the derivative of f, is equal to the limit as h approaches 0 of 4x plus 2h. So I'm going to take 0 and use my substitution rule and plug it in right there, and that whole thing turns into 0. So the derivative function, f prime of x, is 4x. And we can use this function to find the slope at our given point. Our given point was 1, 3. So I'm going to take the x value and plug it into my derivative and calculate my slope. The slope is f prime of 1, which is 4 times 1, which is 4. So I have a slope of 4, and I go through the point 1, 3. Now I can make an equation. So remember, my slope is 4 and my point is 1, 3. We'll do the point slope form. Y minus 3 equals 4 times x minus 1. I distribute the 4, and I get 4x minus 4. And I add 3 to both sides. And it looks like I'm going to get 4x minus 1. Good. That's consistent with what I'm supposed to get. So the equation of my tangent line is y equals 4x minus 1. Now, we can do a quick little sketch of this, or you could put it in on the Desmos graphing calculator that we talked about. But basically, here's my sketch. We have the parabola, which is 2x squared plus 1. So that's going to cross at 0, 1, and then at 1, 3 we have a point. So that parabola looks something like this. Here's the sketch. And then we have a tangent line with a y-intercept of -1 that hits our line at 1, 3 and goes through like that. So here's my tangent line. That's a rough sketch, and again, you can graph the original function and the derivative with any graphing calculator to get a better picture. But there's the process for number 23. I know it was long and drawn out. That's quite a long problem, especially using the four-step process to find the derivative. Our goal in Chapter 3 will be to find some faster ways to get derivatives. Good luck.